Obviously, being an engineer, you will also see the cost factor, right? The cost factor and other things like the cost factor, the environmental conditions, right? So all the things you have to take into consideration before finalizing the choice of a topology. So if I talk only about the choice of topology, so I start with mesh topology, like somebody mentioned in the previous class that what is a mesh topology. So can you see the cursor? So can anyone explain the advantage and disadvantages of mesh topology? So you can see that um, these nodes are connected through different physical links, right? So in case of a mesh topology, the disadvantage, everybody can say that the more cabling required, right? The cable requirement is very high. If these systems are in a room, okay, it is fine that we can go for a mesh topology if all these systems are in a room, right? But if these systems are not in a room and if they are distance apart, then uh, taking cable from system A to system B, right? Uh, and then joining, see, you can see that the system A is connected with all other systems in the network, right? Through a dedicated link, through a point to point link. Can you say what is a point to point link? You have studied point to point link and multi point link. So when I say about a point to point connection, it is like this. Can you say the advantage and disadvantage of a point to point connection? Karthik Rai, can you say? Karthik Rai. Yes, Karthik. क्या वूफर ऑन कर दिए हो क्या अपना? हाँ? वूफर ऑन करके ऐसा कर रहे हो क्या?
Sir, can you hear me better?
हाँ, now I can perfectly hear you. हाँ, right.
My laptop mic, sorry sir.
बोलो क्या, what is point to point link? What is the advantage and disadvantage of a point to point link?
Sir, for point to point, sir, if two nodes are directly connected, it would have a faster communication. But like if we're not directly connected, points will have a higher delay time.
So you can say that yeah, you're right that it is directly connected. So the communication will be faster. It will be secured, because we are not only concerned about a faster communication, we are also concerned about a secured communication between the two nodes. So the communication will be secured. No one can intercept the data which they are exchanging. These two nodes are exchanging. So you can see that this link is secured one, right? But only issue is that if this link fails, the total communication between the two nodes will be stopped. Okay, there is no other alternative to pass the data from some other way, right? So point to point connection has got an advantage that the data will be secured, and it's a faster communication because it is a dedicated link. This link is not shared by any other system. So in that way, this link is faster, the communication is faster and secured. But the only disadvantage is that the failure of this link will disrupt the entire communication, right? And at the same time, to connect more number of systems, right, I need another dedicated link. So this type of a point to point connection, when we it is possible only when we talk about a smaller distance communications. But when we see as from the point of view of an internet, right, from where one person is in here, another person is somewhere else. So in that case, this point to point connection seems infeasible, because you require a lot of cabling requirement is there. So this seems infeasible, right? So but there is a multi point connection where what we can do, we can have a higher capacity link, right, like this. We can have a higher capacity link. Through this link, we can connect multiple systems, right? We can connect multiple systems. All of them will share this link for data exchange, right? This link is common to all the systems, right? But the disadvantage is because this link is shared, or it is used in public, so there is a chance of uh, losing security of your data, right? Your data may lose security. Moreover, there may be a conflict among the stations uh, for access of this shared facility, right? So what you need for a multi-point connection, you need first of all to regulate the access over the shared medium, right? How will you access the shared medium? You so so for that you require some sort of a MAC protocol, right? Then only you can provide a shared access to all. You can distribute the access in an equitable manner to all the stations, right? But at the same time, but another advantage of this multi-point connection is that if a particular path, if a particular portion of the link fails, you may always route the data from some other place, right? So multi-point connection has an advantage that if a particular link or a portion of the network fails, it will not it will not disrupt the entire communication. Rather, some portion will work, so you can pass on your data from the portion which is working, right? But only issues are their data becomes insecure, because it's a public domain. Anybody has a right to anyone can see your data, right? Not a right, but anyone can see your data. So you require uh, you have to encrypt, or you require provisions, right, on this medium, so that the others cannot see the data. Whether you should have a some sort of a link to link encryption or some sort of an end to end encryption, you have to apply, right? Then only you can secure your data. So some data security schemes are to be implemented in order to share this multi-point communication. So that is one two things, okay, regarding this multi-point link. Um, Another thing, some other things are also there when we will talk about the signal to noise ratio, right? That how the signal to noise ratio can be maintained, because that limits the length of the cable also. Okay, so we will come to that point later. Can you say what is this type of addressing, when you talk about addresses, right? What is a unicast address? Can you give any example of a unicast address, multicast address, broadcast address? Ashish Chauhan. Ashish Chauhan. Ashish Chauhan, are you
Sir,
there?
sir, no idea.
No idea. Don't you send the mail to anyone?
Yes, sir.
So when you send a mail to, suppose if you are sending a mail to Karthik, so what do you put in the address field? Huh?
Sir, his user ID.
His user ID, right? So if you are sending a mail to only Karthik, that is a kind of a unicast addressing, right?
Yes, sir.
Unicast means a single recipient you are sending the mail. But if you want to send a mail to the entire class, like you must be having a group mail ID. I think that your batch ID must be there. ECE, ECE section A or ECE section B or like that. There will be a group ID, right?
Yes, sir.
So if you send a mail to the group ID, group means like suppose if all the students in this class will be the recipient of that mail. So do you send that to individual ones or you use a group ID to send the mail?
Group ID.
Group ID, right? So that group ID is called as a multicast addressing, right? Multicast addressing means all the members in your class are a member of this ECE group, right? So
Yes.
once you send a mail at the ECE group, that goes to all the members listed in that particular group, right? Can you say now what is multiple unicast?
Sir, uh, sending many mails to
Sending many mails to
means sending to many persons.
multiple unicast. I am asking. There is a multicast we discussed.
Yes,
That
sir.
multicast is that we are sending a mail to a particular group address. So all those who have subscribed that group will receive a mail which you have sent, right?
Yes, sir.
But I am asking what is multiple unicast? Like in a WhatsApp group, you are sending a message and it will be received by all the members in that WhatsApp group. Similarly, I'm giving an example of a mail. Uh, I'm asking now what is multiple unicast? Anybody can answer what is multiple unicast? How will it be different from multicast? See, it will determine the load, right? It will determine the number of copies which are to be generated by a source. When I am saying multicast, right? And when I am saying multiple unicast, I just now mentioned what is unicast. Unicast is that you will be sending a mail to an individual, right? A copy of the mail will be received by an individual recipient. And when I am saying a multicast, I am sending a mail at a group, Google Groups, so that all the members who have subscribed that group will receive that mail. But when I say multiple unicast, anybody can give any example of multiple unicast? We are used to do it, multiple unicast. When I am sending a mail at btech 1001 dot 18 sorry 19 at bitmeshra.ac.in, and I am also sending a mail at btech all the students who are the members of this group, EC group. I will be writing their email IDs separately, right? So this is what I am doing, multiple unicast. I am sending a mail The mail will be received by individuals, right? To all the members, the same copy of the mail will be received by all the recipients in that group, but on their personal IDs, right? So that is called creating multiple copies. Multicasting में क्या अंतर होता है? Multicasting में we create only the source generates only a single copy, right? But in multiple unicast, if there are n number of recipients, n number of copies will be generated by the source at an interval of few seconds, right? Are you following? And what is broadcast? Ashish, what is broadcast?
So like we send message and whoever receives it.
Whoever receives it, or the message is flooded in the network, right? Everybody who is there, like we receive messages, mails, even we have not subscribed to them, then also we are receiving it. So broadcast means, if I say ideally, it should be received by all the members in the network, right? It is broadcasted. So it is broadcasted means multiple copies of the same messages are generated or duplicated, right? At each point, I will tell how does it work: broadcast, multicast, unicast. That how many copies are to be generated from the source. That how do we minimize the load in multicast, right? What is multiple unicast? Okay, so broadcast means it is to be received by all who are connected in the network. So that is called as a broadcasting. Like we receive a match broadcast, whoever is tuned in will be able to see the match, right? Broadcast. So going back to the topologies, right? So we started with the mesh topology. So mesh topology finds application in some of the cases, right? But the only disadvantage where the distance is less, preferably in a room or where all the devices are connected. So we have a dedicated path, secured path, but the cabling requirement is large, right? Coming to the bus topology. Can you say what is bus topology? Anyone? What is bus? See, this is a bus topology, you can see. Okay, there is a shared medium. I can show you here. Just now I was showing. There are. This is a bus topology. The systems are connected in bus topology. Bus topology means the stations are connected through. This is what the network backbone. We say the backbone line. Okay, or the physical link through which the stations are connected through a drop line. Their stations are connected through some tap. Okay, it's tap. Their hardware interface here that we say as a tap, and through that they are connected through a drop line. This line is called as a drop line, right? The stations are connected through a drop line to this link, okay, where we say it as a tap. It is hardware infused, right? So so the data transmitted by any station, suppose B transmits the data transmitted by V will move in both the directions, right? Will move in both the directions, and all the members. See, here there is no security of data in bus topology. The data will be received by all the members who are connected in this bus topology, right? So whether it is intended for C or not, whether it is intended for C, station C or station D or not, but they will receive a copy of the data which is transmitted by B to A, right? So the data will flow in both the directions. It is bidirectional data flow, and it will be received by all the stations connected in this bus topology. Now my question is that who removes this data which is transmitted by B, a copy of which will be taken by A, then who will remove this data packet from the link? Who will remove? Mohammad Sahil, who will remove? Mohammad Sahil.
Yes, sir. Yes, sir.
Who will remove the data? Have you got my question? That when the B transmits the
Can you
data.
please pardon?
Yes, I am repeating. I am saying that when the B transmits the data packet flows in both the directions, right?
Yes, sir.
A copy of which is received by A also, C also, D also. But this data will travel in the bus for an infinite period of time. So this data is to be removed, right?
Yes, sir.
If its job is over, then this particular data should be removed from the network. So who will remove the data? Who will remove the data?
Sir, no idea.
Anyone else? Anyone else who can say? Anyone else? Kanishk? Kanishk?
Yes, sir.
Can you say who will remove the data?
No, sir.
See, it is written in the diagram itself that there are terminating resistance at the end, because we need to remove the data. Otherwise, what will happen? This data packet will keep on circulating in the network and will unnecessarily waste our resources, right? So there is a need to remove this data, because if its job is over, this data packet should be removed from the link, right, from the network. So there are terminating resistances you can see at the end of the cable. There are terminating resistances. So once this data packet reaches at the end, it gets absorbed at the end, right? So this is how the data packet is removed. This is a very important thing that one should understand, that suppose if some station has issued a packet, right, the data packet that will travel in the network, right? So, and already station A has copied it, so its purpose is served, but the data packet will keep on circulating in the network if it is not removed in time. And if it is moving in the network, what will happen? It will unnecessarily exploit the resources, right? So we have to save our resources, right? And in that way, there are other ways also in internet that how we can avoid misutilization of the resources by a packet circulating indefinitely in the network, right? So we will see that. But for a bus topology, there are terminating resistances at the end. So the packet coming, how the packet is moving in the network, I'm saying terminating resistances. You people are not asking. When I'm saying it, there are terminating resistances. So how this will be absorbed? How the packet will travel? How the packet will travel? Manish Kumar, how the packet will travel?
Sir, in bits.
Yeah, in the form of voltage pulses. You have just studied the coding, encoding techniques, right? You have studied the encoding techniques. So the system, this pulses, so it will travel in the form of voltage pulses, right? It's a bus, it's a wire, right? It's a cable. So it will travel in the form of voltage pulses and it will be absorbed at the end, right? Is it clear? Can you say the advantages and disadvantages of the bus topology? Manish, can you say the advantage, disadvantage?
Sir, the network line is shorter. Bus topology. Bus topology.
Shorter आप कैसे बोल सकते हो?
Shorter, sir, because a single line runs from the sender.
See, this line is. Can you imagine that how you had been in the campus, right?
Yes, sir.
Earlier. Can you say how your hostels are connected?
Sir, through roads.
No, I'm asking about the internet part.
Sir,
Like
LAN.
through LAN, right? So
Yes,
in each hostel has got one LAN, right? Hostel 12 का एक LAN है, hostel 7 का एक LAN है, hostel 6 का एक LAN है. But how those hostels are interconnected? Even you are connected to the main building, even you are connected to the other part of the campus, right? If I'm talking about the intranet part, right? Or if I say about the internet also, where you are connected not only to the internal internet, but local internet, but to the global internet, right? So can you say how those are connected?
sir. I don't know, sir.
Have you seen? You must have seen that generally कभी-कभी आप जाते हो रोड पे तो खुदाई हो रहा होता है कहीं पे साइड में they put OFC cables, right?
Yes, sir.
You have seen that?
Yes, sir.
Those cables are called basically the backbone cables, right? Backbone तो आपको पता ही है, backbone जैसे हम लोगों का जो backbone है, that is basically the main support of our human body, right? So backbone you can consider, we say a backbone network. Backbone network you can consider here as a high speed LAN, right? High speed LAN or high capacity LAN will be an appropriate word. High capacity LAN. You have a LAN in your hostel 6, 7 जहाँ पे भी आप रहते थे. And then I think you must have stayed in hostel 10 first year. After first year you have left. So hostel 10 or 11. So there you have a LAN. Then all those. So in the entire campus we have this backbone network lying. So all the hostel LANs which are smaller LAN, suppose hostel 10 का जो LAN है वो इस बड़ी LAN से connect हो गया, right? Hostel 11, hostel 10, like that, or the LANs are connected through this. So this backbone network which is lying in our campus, which is adjoining all the hostels, okay, which is interconnecting all the hostel LANs, is basically a bus topology, right? Is in the form of a bus topology, right? So you cannot say that the distance is less, right? Yes, distance is limited by some factors that we will talk about later, that what is the maximum length of a bus topology or a bus LAN can be, right? How long a bus LAN can be spreaded, that we will talk about later, right? That which are the factors which limits the length of a bus length of a bus LAN, right? So other than that, what you are saying about the shorter part, so don't stress on the shorter part, because you cannot say it is short, right? It is a shared, because it is why we are discussing this, because we are discussing all these topologies for this to design a LAN, right? To design a local area network. In the first module, we will be studying all these topologies, LAN, transmission media, then followed by the intermediate devices like routers, bridges. So why we are studying those things? Just to, so that we are able to design a LAN, right? A local area network. And being an engineer, how those things will be designed, like what are the things we should take care of while designing, which topology we should select, which transmission media will be suitable for a particular topology, right? So what are the what data rate we are supposed to achieve? Okay, to achieve that data rate, which transmission media can be used, what will be the cost of the overall infrastructure, right? Overall project. So we need to focus on each and every aspect of LAN designing, right? So in that process only we are discussing about this bus topology. So the length is not a factor, but as you can see that it's a common path, right? The data moves in both the directions, right? It's a common path. So if any failure of this link, of this cable, any cut on this cable will disrupt the communication, right? So that is one thing. Then another difficulty with bus topology, because as I said, these stations are connected through a their hardware interface through these tabs, right? So they need to be, it is very difficult to connect, fuse these stations on this bus LAN. So if suppose you want more number of stations to be connected, or means frequent changes, right, in the stations, so that is not very much feasible, because this connection changing is not very we cannot do it very frequently, because it's time consuming and it requires a lot of effort to do that, right? Then this is about the bus topology, that the two flows in bus topology. One is that a cable cut can disrupt the entire communication. Secondly, if you do not want that your data should be received by other stations which you do not want to send them, but if they are connected in a LAN, a bus LAN, it will be received by all the stations which are connected on a bus LAN, right? You cannot prevent it. So there are some ways by which we can prevent that, right? We can, how can we prevent it? Someone can say, ये तो आप data communication में पढ़ के आए हो. What is there in the data packet? What is there in the data packet? See, we have some control information. Other than the data, we have some control information, right? In the control information, we can fix the source address, destination address, the length of the data, serial number. So to send it to a particular destination, right, we will put the destination address. So by providing a source some control information, or we say some sort of a control information into this, into a packet itself, will solve this first problem, that it will not be received by all other nodes which are, it will be received only by the recipient, not by any other unauthorized person, right? So that will solve that first issue, but this issue remains as it is, that cable link cut will disrupt the communication. Moreover, as I said earlier, that the bus topology has a limitation of a maximum length limitation, because as I told you just now, that this data travels in the form of voltage pulses, right? So if the voltage pulses are to traverse for a longer distance, right? Generally what happens? Can you say, suppose if I am seeing the voltage at a distance of 500 meters or 1000 meters, right? Or I am seeing the voltage labels at around 500 kilometers. Will they be same? Will they be same? Being an electronics engineer, you should answer it. Will they be same?
No, sir.
No, sir.
Why?
Sir, dissipation due to heat loss and all.
Heat loss, noise, right? Attenuation hoga, right? So if we say that, so voltage labels will not be same. So that factor limits the use length of the cable. क्योंकि हम लोग इसको क्यों use करते हैं? We will study the MAC protocols. At that time, I will mention that we detect the collision also. Are you aware that which LAN you are using nowadays? Which LAN you use? You must be using some LAN port in your laptop. You must be using some sort of a LAN connection while you were in campus or presently at your house also. Can you say which LAN you are using? One is a Wi-Fi, right? But if you are using a wired LAN, which LAN you are using?
It's a twisted pair.
Twisted pair is a transmission media, right? Twisted pair is a transmission media, but if you see, you must be using an Ethernet LAN.
Yes, sir.
Is it not? So there is an Ethernet LAN. We say it as 802.3 Ethernet. So there is a network interface card in your machine, right? That allows you to connect through a cable to the shared this internet, right? So if you see why I bring this Ethernet, as I told you that if I am talking about this bus topology, there are two flows. One is when I mentioned that if we put control information in the packet itself, that कि ये packet किसको जाना है, then that particular station only will copy that packet, right? So we can avoid unnecessary delivery of packets to unauthorized persons. But there is another issue also that I told that, see, whenever we get any shared resource, what do we do? जैसे हम लोग रोड की बात करें, right? Generally हमारे यहाँ क्या हो जाता है? We result in a congestion on the road. Why? Because everybody tries to go first. If there is no control, if there is no traffic light, right? Everyone tries to go first, and what happens? Nobody is able to move out, right? क्योंकि jam हो जाता है. So there should be some access mechanism, right? There should be some access mechanism to find out, right? That who will transfer, right? और ऐसा भी हो सकता है कि दो लोग एक साथ ट्रांसफर करेंगे तो क्या होगा? There will be a collision, right? Data will be collided. So if collision occurs, first of all, we have to detect the collision, how the collision has happened, right? So if I say about that MAC protocol, that क्योंकि collision होना क्या हुआ, जैसे I think you must be aware that nowadays we are getting these expressways, right? So on these expressways, generally, or you must be watching many movies also, that on an expressway when the two cars collided, then what happens? पीछे से आ रही हुई कार का क्या होता है? All other cars all other vehicles which are coming from the back, they also get rammed into the earlier collided vehicles, right? So what happens? A similar thing. So once a collision occurs in the network, right? that results in many such collisions, right? एक बार जब collision शुरू हुआ, then we will take some analogy and we will see that once a collision starts in the network, it results in many collisions, right? और उससे क्या होता है, आपका data loss होता चला जाता है. We do not want that. What we want, we need some MAC protocols to control the access so that two devices at a time should not transmit. But is it possible that on this internet, on a network where millions of devices are connected at a time, even millions are, I am saying, less, right? Connected at a time, and if they are sending the data, they are exchanging the information, and is it possible that they may not collide? Yes, to some extent, but it is not perfectly guaranteed that they will never collide. It is not like that. They will collide, but collision possibility cannot be mitigated, right? But it can be cannot be avoided, but it can be reduced. So we use in Ethernet, we use a protocol, MAC protocol, as CSMA CD. Carrier sense multiple access collision detection. The CD is for collision detection. आप लोगों ने सुना होगा ये नाम, CSMA CD, then CSMA CA. This is used in wireless LAN. Okay, CA stands for collision avoidance. Okay, we will talk about these things in detail. The collision detection. So how the collision will be detected? So suppose generally दो गाड़ियां आपस में टकराती हैं तो क्या होता है, आप बताओ जल्दी से, क्विकली. बताओ शांतनु, if two vehicles are colliding on head, what will happen?
It will cause destruction.
But there will be more energy will be released. No, if I am saying there is a head-on collision, the more energy will be released.
Yes, sir.
Right? But if the two signals are colliding, right? If there are two signals which are good in strength, if they are colliding, suppose a 5-volt signal is colliding with a 5-volt signal, right? So what will it may be after collision, the signal level may be up to 8 volt or 9 volt. It may reach. Is it not? Is it not or not?
Yes, sir.
Then easily one can detect that a collision has taken place. If the signal level rises beyond a particular limit, one can detect that the collision has taken place. But if the signal strength is too weak, right? If the signal strength has become too weak, weak क्यों हो गया? क्योंकि वो बहुत ज्यादा दूर चल के आया, तो वो weak हो गया. And once the signal level is weak, and if it collides with another 5-volt signal and the signal level is weak, so it will not affect much after collision. So energy difference will be, the signal level will not rise much to be detected as a collision. So that restricts the that puts a restriction on the length of the cable in a bus topology, right? We will see in detail. Okay, so I think already time is over. So please join in time. I request all of you to please join in time. Okay, I'm stopping it here. If any question is there, please ask. If any doubt is there. Okay, then I'm stopping.